Greetings. Welcome to Calculus in the PM. Just had our fire drill. Continuing with the inverses. Here's the summary. You don't have to memorize a formula because it's going to be, I'm not big on memory work. Anyways, this here though must be known, right? If you take the function and you put its inverse inside it, the x is what comes out of it, right? You just start with what you started with. Okay, and we worked that out a little bit last class, with sines and cosines and their inverses and how they work. Now, what if we did the derivative of both sides with respect to x on this? So d by dx, for the left, for the right. But we're going to use prime notation. It's just more compact. What does the left side become if I use that, if I do the derivative? Well, this is a function inside a function. So we do the derivative of the outside, leave the inside alone. So this turns into f prime, leave the inside alone, times the derivative of the innards, right? I'm going to just change the color only to emphasize that's really what we want. The right-hand side is easy. Derivative of x is 1. Then isolate, because what's the derivative of an inverse? It's equal to 1 over, and then just isolate that. Okay, that's the formula you really need. As long as you know what an inverse is, though, you can come up with that formula, and like I can do it quicker than I wrote it down there. The other thing that comes in handy when you're working with trig functions is Pythagorean identities. Now, I think we all know cos squared plus sine squared of y is equal to 1 or x or theta or whatever. Yes?
So it's an inverse times an inverse?
Oh, which?
Oh, so you're just dividing the inverse from one side onto the other side?
That is from here, yes.
Okay.
I've isolated for the derivative of the inverse. And remember, this is composition, it's no multiplication like as in, this is the inverse inside the derivative of the first function, the outer function, right? Okay. We'll come up with things like this. Now, incidentally, everybody I'm sure knows the primary Pythagorean identity. Do you guys know how to come up with the other two identities if you ever need them? What if you divided everything by, say, cosine squared, cosine of theta squared, or y squared, I guess in this case. What if you divide, you think here, what if I divide this? I can't, it makes it. Cos y, and I divide this by, you know what I'm trying to do anyways. I can't write zeros there because it isolates. So I divide this, this, and this by the cosine squared y. What does the first thing become? 1. Okay, so it becomes 1. What's sine squared over cosine squared of y? Tangent. What did I put equals? I don't know. And it's no. So plus the tangent squared. What is 1 over the cosine function? Secant squared. I'm showing you this because don't memorize the other two. I know you have the primary Pythagorean identity memorized. Then you ask yourself, what if I divided all 3 items by the sine squared of y? Okay, well the cosine over the sine squared is cotangent squared. Sine squared y divided by sine squared y. Okay, 1 over the sine is the cosecant squared of y. Right? Now, that's just setting you up with some skills. You should have those identities memorized, as well as obviously you need the quotient and reciprocal identities for this, right? If you have that, you're good for all. I don't think you'd need any other identities in AP that come. I can't think of any that come across. You're not going to need double or half angle identities. And if you do, you'd probably be given them. Anyways, I can tell you how you get the double identities though later if you need stuff. Anyways, the reason being is that, what if I say from first principles, if we know that the y here is equal to the inverse, that's my function, I got the inverse function here. Well, don't we know that we've got an inverse function here, and we know this, right? We can come up with that formula real quick. Wouldn't dy by dx then be one over, right? Okay, we're thinking this. The inverse function sine arc sine of x. We sometimes say arc sine instead of sine -1. Anyways, so what's the derivative of sine of x? You say it's cosine of x, right? Because I'm trying to apply this formula to it here. So I'm going to say, well, what's this part here? That's the cosine. And then, the inverse here, well, we'll do this one step at a time. It sounded almost rude there. Okay. You guys follow me on this? If you can do your problem right now, then why would you go any further? It depends on how the problem's set up. But, now what? Well, don't we know that, what is this? It's also y. Let's make this, maybe that would be helpful. Okay. Well then, if this is the case, and we know the Pythagorean identity, cos squared y plus sine squared y is equal to 1, let's get this in terms of sine. You guys follow me on this? So I'm applying the Pythagorean identity at this point, right? And so then we say 1 over the square root of 1 minus sine squared y. Well, what did we say that the sine of y is equal to? Because these are inverses, this is true. It's x. 1 minus x squared. This is where those formulas come from. That. Okay. And we already came up with this. Now you could do a similar thing. And you would come up with that for the cosine. Except with the cosine, you just get a negative sign involved. But then otherwise it looks like that, 1 minus x squared. Okay? You could do that if you need to. You don't have to memorize formulas. You can come up with the right substitutions. Likewise, with the tangent, the inverse of the tangent. You could do the same thing here. So if I said, what I'm going to use a little more space here this time, dy by dx. When I apply the inverse formula, what's the inverse formula? Derivative of the regular function with the inverse function plugged in, right? 1 over that. So I'd say 1 over. What's the derivative of the tangent function? Secant squared, yeah. Positive. And then put the arctan function inside this, right? Okay. And then I'm following a similar format to this. Once I got that, the arctan, when I say arctan, I'm talking about the inverse function, okay? The arctan is y. Okay? That makes it a little more compact, right? Sometimes that's helpful. But in this particular case, I could, once I see squares and stuff, think, oh, I can apply the Pythagorean identity. Because secant squared, I want to relate it back to tangents again, right? So 1 plus tangent squared. Where do I get that? I get that from the big blue stuff, right? 1 plus tangent. Okay. Squared. And then, of course, if we looked at what the inverse function really meant, it meant the original function was tan of y, well, that's equal to x. So then we could replace this with 1 plus x squared. And this is what you'll notice on your formula sheets. Now I'm going to just flip back and forth the formula sheet here. Doesn't matter that I did mine in the opposite order. By the way, U is like if you had a bigger expression. Okay. It doesn't matter. 1 plus x squared plus 1, same thing. If you did this with the the cotangent function, you just get a negative sign in front of it. Okay? That's the only difference. So if you know this, you can come up with this in a jiffy. And then, of course, the cosecant and secant functions. Back to this review here. If I said y equals the secant inverse, the arc secant, arc of the covenant, so like Indiana Jones, you're exploring. Okay. X equals the secant of y. So when I'm doing this, what's our first thing? Well, we think the outer function. One over. Now, if you recall the secant function, secant y tan y is what that would. I'm skipping ahead here, I guess. Didn't I? But you know how it's secant of theta, tan of theta, depending whatever the derivative of a secant function? That's one we don't use often, so you don't have it memorized. Okay. Anyways. Now I'm going to skip this middle step here just for brevity, I guess. Maybe I shouldn't. Okay, I won't. Secant tangent, yeah. Okay. That's just applying the derivative there, keeping the inside. Now, like I said, just like the other ones here, that'll be on my y then, my original function. 1 over secant y tangent y. Just like the other ones then. You can replace the y using, you want everything's in term of secant. And you can change the tangent using what I have in green there, the cotangent. No, sorry, the blue.
Isn't that denominator isn't technically cotangent?
You could. You could put it up to the top is what you're saying.
Yeah.
But just stick with me on here. You could, because you won't, if it's helpful in the problem, you can do that. However, if we want everything in terms of what the original function was, all in secants, we can use the tangent is. And the tangent is secant squared minus 1. I can't see mine right up there, so I'm going by my memory. Stop me if I'm making a mistake. My memory ain't great. Now, I'm going to want to keep these positive. And secant, you know how we had to choose an area where things are? I'm going to just throw this in here and you'll see why. Okay, this one will be positive. Trust me on this right now. We can go into details later if we want to. It's not worth it though right now. Anyways, what's secant y again? X. So we can turn this into the derivative. There's 1 over, that should be flat brackets. Now, I did a quick run through of all of these here. Make my denominator line a little better. These are all the formulas. You could quickly come up with all the formulas. I just showed you half of them, right? From here. Now this summary is for if you had then the sine of x squared plus 5x or something like this. That would be your u here, okay? I did the simplest form, x. This applies though. Now, just a second here, I'll pause for a second here. Two different ways of applying this. If you have the formulas memorized or given, it's pretty easy. So let's just take a look at this. But we're going to do it the other way too. So if I do the formula way right here, dy by dx. I say, well, the arc sine of the comet. Indiana Jones, explorer. According to this, u prime on the top, 8x squared is like my u, not u prime. So what would u prime be? 16x, right? So 16x over 1 minus 64, because 8 squared as well, x to the 4. Okay, that's super simple. But you're actually not going to come across problems like that too often. But if you know these, like I'm talking AP. So, what if we did it this way though? I want you to be able to do it without using the formulas, because the other thing is that chances are you're not going to remember them. You could, but if I rewrote, this expression, or this equation here, not as a inverse, what does that mean as far as sine equals? Sine of something equals. What could we say there? Well, you know how, you're not sure what I'm asking, that's fine. You know, if I say y is equal to sine negative 1 of x, that really means x equals the sine of y, right? So give me a statement like that here. What does this mean if you're not talking inverses? The sine of y equals 8x squared, correct? Now, do the derivative of both sides. Implicit differentiation, right? What's the derivative of sine of y? Cos of y. Do the variable match? We're doing d by dx. So does the variable match? No. So what do we have to do right after that? Times? I'm going to call it dy by dx, but yeah, y prime. 16x. Okay? Now what? Hey, this cozy thing I see there. Well, we can isolate for dy by dx. Depending on the problem, that might be, if it's a problem with a given scenario, this might be enough to do it. It depends what's given. Now, we know though that we can go from cosine of y to sines, right? How do you do that? Pythagorean theorem. So what's that? 16x stays the same. Well, what is cosine as far as square root? Yeah. 1 minus sine squared. There's a reason why I did that. 1 minus sine squared of y. Hey, what was y equal to? We said it right at the top in green, 8x squared, right? So if we square that, okay, exactly.
What's the difference between writing that and writing 1 minus sine y?
1 minus sine y.
Because aren't you square rooting it so because it's not cos?
Yeah, I know what you're saying. Good thing you asked me here. Let's just put this in with a number that we understand. Let's just say, what's the difference between this and, I'll go with one where you'd be tempted to do this. 25 minus 16. Now, I chose that one because it comes out to be 9 and you know it's equal to 3, right? But what if we tried the method you said? Is this equal to 5 minus 4? Is this equal to 1 minus sine? Okay, you know, if you have an idea and a hunch and you're not sure, test it out with some numbers you know the answer to. And that's a common mistake. Don't make it. Okay, So if we say that sine squared y is the same as this squared, right? That's sine squared. So if I square this, we've got 64x to the 4, right? Now, it should be the same answer, and it is. Minus 64x to the 4. Now, this is definitely more work, and if you're a memorizer and you know things, fine. However, you could do these from first principles. That's what I'm trying to tell you. And sometimes, actually, the memorized formulas aren't very helpful. The odd time it might come in handy and save you 2 minutes of work. It might. I'm just letting you know that if you're hooped on the test, you don't know your formulas, because it's a lot, you're going to have more to know on the daily test. You could do these by just doing implicit differentiation. That's all I'm trying to get across to you. That's the reason why I'm showing you how these formulas came up. Question?
How do you get the inverse sine y into 8x squared?
By definition, what does this inverse mean? This is asking you, let's do it. This is 8x squared. This is the answer when the angle is y. Do you follow me on that? If I said,
Oh, that's x, yeah. That'll be y.
what sine of what angle gives me an answer of 1 over root 2, or root 2 over 2? And you'd say, radians. Oh, faster. 1, 1, radical 2. This should be an easy.
5 over 6.
No. That's a 45 degree speed, but it's pi quarters. Now, what I'm trying to say is that the sine of pi quarters is equal to 1 over root 2, right? You guys follow that? That's what you guys would have said before. Just because you don't have something
Why
like,
is it negative? Wouldn't it change something?
okay, oh, this here, that's not a reciprocal. That's just arc sine. That means it's the inverse function. That's a notation thing. And you can't, it's not a negative sign as such, no. I think it's a silly notation. That's why I'll tend to say arc sine often. But enough about that. I'm going to just rip through this. These ones here, let's just try the formulas, okay? Y is equal to the secant inverse. 3x minus 4, I'll give you guys a second to try that. And then, this one's a doozy here. Okay, so I'm going to pause, let you guys work. I'll take them up. Okay, here's an answer to the first one. Now we're going to use implicit differentiation to do this one. I'll pause, let you guys rip through it. Okay, so the first step was doing d by dx. 1 mismatch, so 1, then dy by dx. Apply the formula, the derivative of the innards, right? Making sure that you have the 3y turning into 3 dy by dx. And the bottom was the innards squared plus 1. We got that from this formula, right? Okay. Once we do this, this is strictly algebra now. Isolate for dy by dx. I'm going to get this denominator multiplied up to the top. So, I'll write it down. Okay, so once we have that, don't multiply out the square. If I just want to isolate for dy by dx, I've got that and that I want to do there. But we do have to multiply and distribute, right, there, and then I have to distribute here. But I'm going to keep that as x squared plus 3y all squared. I'm not going to multiply it out. Okay, so the first term, is just x squared plus 3y all squared. Then I distribute to the next term. So that with a dy by dx attached. Yeah, I'm going to do it that way. Yeah, I am. I did it a different way last year. I was just taking a look at it. Okay. X squared plus 3y squared dy by dx. I've distributed. Oh, I didn't write that down correctly. There we are. Plus 1 plus dy by dx. Yucky. Now what? Did I make a mistake or anything?
Are you allowed to just
Okay.
take the one from the inside and switch it to the other side?
Yeah, which side do we want to put our dy dx's?
No, like, you know, it's 1 plus dy over dx. Can you subtract it to the other side, or can you not do that?
Oh, son of a gun, I didn't put down the right-hand side first. Yeah, you're just strictly think of this in algebraic terms. Dy by dx is something you want to isolate. So you're going to use adding or subtracting. And let's group our dy by dx's on the left or the right side. What do you guys want? I've heard left and right.
I hear.
Right-hand side, I think so.
On the right.
Okay, so I'm going to subtract I'm going to move this one to the left by subtract. I'm going to subtract this term and subtract this term to the right. Okay, I'm going to move it that way. Just so I'm going to keep this.
Can we get to divide that one?
Don't have to divide anything right now. Yet. We will, but. Plus 1 minus 2x. Okay. I got 3 dy by dx. I've got minus x squared plus 3y all squared dy by dx. I got minus dy by dx. Oh, yeah. Is there something in common on the right-hand side? Yeah, dy by dx. Now, I could do this I would do this in one step, actually, typically, but I'll write it out in 2 steps, just so I'm not doing anything to the left-hand side. But I will put dy by dx, because I'm factoring that out. 3 minus x squared plus 3y. You guys follow that? And now you can just divide that, and you've got dy by dx isolated. You could group 3 minus 1 as 2, right? So that would be your last thing, is to isolate for dy by dx. Something like that, I'm not asking you to multiply that out and try to simplify further. That'd be ridiculous. DQ. What you really want to be able to do is apply this, and this is a common type of question. You will most likely see a question like this. So, what's the value of the inverse's derivative at -2 plugged in? Do you guys follow that? So, I actually, like I say, if you know what an inverse is, f of f-1 of x is equal to x. And I just think, oh yeah, derivative of the outside, leave the inside alone, and I just isolate for it, and I've got the formula. How? I still go through this in my head. Like that, though, but I mean, the reason why I do this is what I want to apply this. Really, if I'm trying to find this, I'm trying to find f Okay, that's strictly what was asked right there. Well, I apply that. I put that negative 2 in here. Right? Okay. This is what I want to do, but I got to use a chart to do this, and I don't know what the functions were. And this is most likely what you'll come up with. You will have some, there's a good chance you'll get something with trigs of functions involved, but usually they can be done without memorized formulas. They really can't. And don't get too hung up on memorizing the formulas, because you can always work them out from first principles. Okay. If you're good with memory, go ahead and memorize them. What does this chart really mean here? Well, this is the function, what you plug into the function, the x values, into the original function, right? How does the inverse work? So it's like you're reversing things, right? Underneath this, if you see a chart like this, I suggest you write underneath this. If the inverse you know how you reverse things on the inverse function? You see how the x and the y's are, right? Think of it this way. Because what does inverse mean before we even get into calculus? Well, if I put negative 3 into my function, I get 2 out of it. If I put 2 into the inverse, what do I get? Negative 3. So this is why I'm saying, if I put this x value into the inverse, I get. So it's reading the chart right to left. Do you follow that? Don't worry about the derivative at this minute. Now, often, an AP question will then just say, let the function g be the inverse function of f or something like that. It's just another reading step to make you think things through. Now, we are asked for what's the inverse when negative 2 is plugged into it. And what would you guys tell me?
Wait, no.
I heard 0.
But it's the inverse of 0, which makes
It's the
0.
inverse, yeah. So, that's the direction I'm reading this, right? So, I'm saying when I start at negative 2, put it into the inverse, I get 0 out of this, right?
But if it's an inverse, wouldn't it be like, wouldn't the 1 go above the 0?
Okay, but I'm strictly evaluating the inside of this.
Yeah.
So,
Is the inside an inverse as well, though? Or is it not?
okay, this part here
Yeah.
is strictly the inverse, no derivative on this part of negative 2. Right? That's what's notated. I'll worry about the derivative after. And I said when I put negative 2 into there, I get a 0 out of this, right? That's what I circled in green. Okay. Now, you're asked, what's the derivative when you got 0 plugged into it? It's negative 1. You got that?
Kind of.
Because now you can ignore the middle column. And I'm just saying when the x value is 0, what's the value of the derivative when I plug 0 into it? That's where I come up with 1 over negative 1. So negative 1 overall. Now, they're not too complicated if you truly understand what the formula is all about. And like I say, you don't have as much algebraic work, but you got to be exposed to these here. Now I'm going to scratch some questions from this, because I know in the past, before I knew better, I focused too much on computation stuff.